All right, class. Yes. All right, so today we have this is 5th hour, right? Yes. Okay, 5th hour. This is Algebra 3. We are going through, we have our pages in our interactive notebook. This is going to be 17 here. This one's going to be 16. And this thing right here is also, the graph paper is going to be on page 16. Okay, so if you have your notebook, for those few people who actually do have it right now, that's where they're going to end up at. If you don't have it with you, just hold on to these pages until I can get it back to you, okay? So I'm going to, because Monday's going to be a special day, we only have 30-minute classes or less, so I'm going to try to get it graded, your notebook's graded today, and then we're going to finish this lesson on Monday. Because we really can't do a whole lesson on Monday anyway. So I might as well split up today's and then, you know, get some stuff done. All right.
Do you want this extra space with this graphic?
Yeah. Okay. Yeah. All right, so let's take a look. On this first one right here. So let's take a look for f of 0. What did we say f of 0 was? Try again. 32. Now, the reason why it's not 1. So 0, if x is 0 right here, anything to the 0 power is times 32 is 32. That's where that went. Okay, a lot of people missed that one. Okay, so it's a 1 times 32. Then f of 1 was, f of 2 was, and f of 3, 13.5. Very good. All right, so now for this thing right here, take the cake. Now, okay, so this is a kind of a hard concept to understand. It is a super hard concept for most people to understand because if the first person takes 1/3 of the cake and each person takes 1/3, how many people will actually get cake?
Wait, say it again.
If the first person takes 1/3 of the cake, and each person after that also takes 1/3, how many people actually get cake? 3. Because there is a specific wording to go along with this. So, first person comes in and takes 1/3 of the cake. The second person takes 1/3 of what's left. Okay, so now I have an analogy here. Okay, so for this, you know, this actually helped out one of my other classes. So let's say, for instance, so for my sake, I'm actually going to the back of the graph paper so you guys can see this. All right, let's say, for instance, some people in here got a job. Okay, you got a job. Okay, you flip burgers at McDonald's, right? Okay, so at that job, you have a 1-month paycheck. Okay, at that job, you have 1-month paycheck. I'm gonna make the math easy on this. So let's say you make $900 in that 1 month. Yes, the government. Okay, they said you ain't need no money. Okay, thanks Obama. They increase your taxes and say, hey, those people that work 0 hours need to get some of that money. And so we're gonna say that the money that you're going to take home from that, they're going to take away 1/3 of that. If I'm going to take away 1/3, what is 1/3 of 900? 300, right? So I'm going to subtract 300 from that. So I'm going to take away 1/3, so minus 1/3. Okay, so that's going to be 1/3, which is 33.33%. Okay, 33.33%. So it's taking away 1/3 of that whole thing. Okay, so how many thirds do you have left over? You have 2/3 left over, don't you? Yeah. So if I have 2/3 left over, so after I took away that, I have $600 left, right? Okay, then your mama says she ain't wash your chones for free. Okay. Yeah, so anyway, your mama says she take half what you bring home. Whatever hey, this your mama and this is every month. Okay, listen. Your mom paid for the whole house. You don't live in, Okay. Yeah. Anyway. Listen, this is actually pretty fair. So if your mom said, "All right, I'll take half of what you make a month." Listen, chill, Linda. All right, so now I'm just this is part of a story, an analogy to what we're talking about. So your mom is only going to take half of what you have left, right? So she's not taking half of the original, she's taking half of what you had first, right? Okay, so now she's taking half of this, which is going to be, okay, so it's minus 50%, right? So if she was taking half of the original, she would take 450, wouldn't she? Because half of 900 would be 450. She's just taking half of what is left. Your mom supported you for a while, okay? Anyway, all right, so she took half of what you had, what you brought home, okay? So you're going to be left with $300, right? Okay, so now, with that $300 you have left, okay, this is your spending money. But then you have this addiction, okay? There's an addiction, okay? Taco Hell. They take half of your money, okay? Because you got to go there all the time. You're going to Taco Hell, and trust me, okay, Taco Hell is going to take half that money. So what would that be? That would be 150, right? So it would be minus another half, which is 50%, right? Because Taco Hell is going to take some of that, right? So the money that you're going to have is 150. Now, if you notice, look at my pattern that I did right here. I started by taking away a third, right? And then I took away 50%, right? Then I took away another 50%.
You started with 900 level 150.
Okay, so now, hey, welcome to adulthood. So did I actually take away 133%? I did not take away 133%, did I?
You took it separately from each value.
Yes, that's how your taxes actually work. They don't take away from your whole amount in the first place. You could take portion after portion. Yes, you will. Okay, but thanks, Obama. You know what? They got to give it away to someone else. What? Go ahead. Okay. So now, you're only taking away what is left. So if I did the math on this correctly, if I took away 1/3, what was left here? 2/3, right? Okay, if I took away half here, I took away 50%, what was left? Another 50% of that, right? So the analogy is, you're not taking away the combined percentages, you just take it away one after another. So, let's go back to that cake problem. So, we had, let's say I have some student. Let's call him Justin, okay? He's going to come in, he's going to take that big slice of cake, okay? No one takes any cake. How much cake is left? A whole cake. So I'm going to say one whole cake. Yes? So, I have one whole cake left. But now, if I'm going to take away 1/3 of the cake, so I'm going to make my cake round just to make sure. So there we go. There's my cake. So if I take away 1/3, what is left? 2/3, right? I'm going to have 2/3 of that. Because that is what is remaining. Because that is what is remaining. So another analogy, let's go over here. And so let's say, for instance, I go shopping. Okay? Y'all go shopping. Where do you shop at? Target. Let's say, okay, like clothing. Let's do like Ross. Okay, Ross or not K Momo. Seriously, no one go there. All right, so we're going to Ross. And the reason why I say that is because they always have like super clearance deals. Because it's like 60% off something, right? Say yes. Okay, so 60% off. So if I have that $100 dress, the reason why I say that, I have to go there all the time. I got 4 daughters, and so, yeah. Okay. So if it's 60% off, think about this. 60% off. 60% off. I'm using the money value, and I'm using nice round numbers, so it works out very well. 60% off. How much is left? You took off 60%, but how much are you paying for? 40%. Very good, 40%. That's what I'm trying to get at here. You're taking away 60, but you're paying for 40%. So if I did the math correctly, okay, 40%. So after you take away 60% of this, you're going to be left with. Don't worry about taxes right now. Okay, we're shopping in Las Vegas. They don't have sales tax in Las Vegas. Yeah, they don't.
That's a lie. That's a lie.
No, they don't.
We would expect California.
No. Nevada doesn't have sales tax because they have casino revenue. So they don't actually charge. I said Las Vegas. Yeah, they have. Okay, they don't have a sales tax.
Yeah, casinos here.
Yeah, that's different though. Anyway, so right here, but now we get an additional 10% off. So let's say, for instance, that there is someone with their head down on their desk trying to take a nap right now. I'm going to look away, and however that person gets woke up, you know what? It's on them. Bro, it's on you here.
Hey.
So we got an additional 10% off.
Got that Groupon.
Yep, got that Groupon, right? Additional 10% off. Am I taking 10%? So am I doing 70% off now? No. Additional 10% means it's 10% off this one. So 10% of 40 is, say 4. So I'm paying for 90% of this. So that would give me $36. It's not combined together. I don't add that up to be 70%. Because if I did do that, that means I would only be paying 30, right? Okay. So, now, that's the same thing that we're doing. You pay for what is left. You pay for what is left. So now, if I started off with 1, right here, if I start off with 1, and I multiply that by, what is left? 2/3, right? So after we had that, remember, just making up a name for this, that kid Justin, he took away 1/3. Okay? And then what's left? 2/3. Now, what would I do to take away another portion of that? I'm taking away how much of it? Another 1/3 of what's left, right? So if it's another 1/3 of what is left, I'm going to multiply that by. And that would be times 2/3 again, right? Because that's what is remaining. Because that is what is remaining. So I could multiply that, and that would be 4 over, say 9. 4 over 9. But now, we had a person come by, okay, a hypothetical person, let's call him Jake Quellen, and take another 2/3 of that. Take another 2/3 of that away. And so I would multiply that by 2/3. And so it would give me 8 over, very good, 8 over 27. So that's 8 over 27. But now, I have another hypothetical person. Let's call this person Angel. Coming to get some of that cake. And going to take another third away, right? Going to take away another third, so what's left? 2/3. So I'm going to multiply by 2/3 again, right? Which would give me 16 over, there we go, 16 over 81. So that's by taking away 1/3 every single time. But if you look at the pattern, what I did, what is happening every single time? Multiplying by 2/3. And what did I say that repeated multiplication is? Exponent. Very good. Repeated multiplication is an exponent. So if I'm going to write this out, I'm going to say that C of n is equal to, okay, what is my initial value? 1. 1 cake. Times what? 2/3. And repeated multiplication is an exponent, right? It's an exponent. So what am I going to put over here? N. Now, if you guys remember from yesterday, yesterday we were talking about the difference in between recursive and non-recursive. Okay, explicit, which is something specific. We want a certain term right there. So if I'm doing that, I'm thinking about it, I'm like, okay, so recursive requires the previous term. And if I'm doing a recursive problem, I have to have a previous term. So in a definition for recursive, what do I have to put in there? Say it. N minus 1, right? For the definition, it has to have an n minus 1 because that's my previous term. So it's got to have the previous term. So I'm going to do this in the calculator for explicit first because we did this. It says right here, write 2 definitions, recursive and 1 non-recursive. So here's my non-recursive. And I'm going to show you in the calculator. So let's go ahead, take a look at our calculators. And from my calculator, so we said it was 1, right? Times, parentheses, control, divide, 2 over 3, close, caret. Now, let's say, for instance, okay, let's just check to see what my calculator says. What would my 4th term supposed to be? Say 16 over 81. Because that's what we did already on our paper, right? So could I just have jumped to the 4th term? There we go. That's what explicit means. I could jump straight to that term. Instead of actually going and having everyone in between. You don't have to have every single answer all the way. You can jump straight to that term to figure out what that one would be. So that is explicit. Now let's take a look. A recursive would be, actually no, let's finish my definition. So if I were to finish my definition here, what's needed? Let's define this. What values of n am I going to use? N. What values of n am I going to use? I would, but what am I doing? Look at the table. Starts where? It starts at 0, doesn't it? It starts at 0. So defining it starts at 0. So the values for n would start at 0 on this one right here. This is explicit. A recursive is different. So if I was going to do recursive, what would I always have to have when I'm doing recursive? Someone say first term. Yeah, because recursive means I have to have my previous term to get the next term, right? So I would say, if this is recursive, I would say C of 0, very good, because that's what's given to me, right? Is equal to 1, very good. So C of 0 is equal to 1, and then what else could I have? Okay, so now I'm going to say C of n is equal to n minus 1, but how do I state it? Not just n minus 1. No. Okay. What means the previous term? C of n minus 1. C of n minus 1. And then it's going to be multiplied times 2/3, right? And now given that, so let's go through and define this now. Define it for the values of n. So n is going to be greater than equal to? No, not 0. Why 1? Because the first one is given to me, right? In a recursive, the first one's going to be given to me, but the rest of them here are the ones I'm going to find. That's what that means. So I have the first one, and I'm going to find all the rest. So starting at 1 and so on, because the first one's given to me. All right, so let's take a look at 3. What is a reasonable domain? Now, domain means what values of n am I going to use? Yes. Oh, restroom? Oh, wow. Okay, I thought you were going to have like an answer. I got all excited. I really did. All right. Go ahead. Go. It's all right. Okay, this goes back to my plane analogy. Okay, how many people are on a plane? Who is on a plane? Not negative people. You don't have negative people on a plane, right? Y'all saw the video. If you're negative, you get thrown off, right? They drag you off. So no negatives on that plane, right? Are you allowed to have 0 people on a plane? Yeah, you're allowed to have 0 people, right? And keep going. Hey, it's parked. It's parked. There, look, people on a plane. No one's there, right? It's just in park. Okay, sitting over there in my driveway right now. So it's okay. Yeah, I know. How many people can I fit on the plane? A lot, right? It's going to be a whole lot of people. So it's going to be just forever, right? Wherever, you know, we're going to keep making bigger and bigger planes. And it's just going to keep getting, you know, larger and larger, right? But now, remember also the analogy. Okay, remember my homie from, that was in the Iraq War? Remember that guy? Okay, he lost his arm? Okay. What, are you going to say that guy's like 0.9 of a person? Trust me, yeah. You wouldn't say that to him, especially to his face. Man, yeah, no. You wouldn't do that, okay? So, anyway, he get beat down with one arm tied behind his back. He carries it around with him. No, but now, no. No. Okay, anyway, so listen, you're not going to consider someone less than a person, right? No, you're not going to consider them half a person, right? No, they're not less than a person. You're not going to have fractions of people. You're not going to have any decimals, right? So the values of this are going to be starting at 0 and going through positive integers, right? That is the domain that we're going to talk about. But now let's take a look. What is a reasonable domain for this? Are we allowed to take 0? Yes, we got 0, right? So we could take 0. So it'd be 0, n, and how far is it going to go? It's actually, if you think about it, it's going to go to infinite, right? Because no one's ever going to take that last piece, are they? They're not taking that whole last piece. They're taking chunks off of it. They're not taking the whole last piece. And so what we're doing here is we're going to actually, you know, theoretically, it goes to infinity. Yes? Okay, good. All right, so this is what we're going to do now. So this, we're going to hold on to this for Monday. We're going to pick this up on Monday right here. You guys are able to do this one right here. You're able to do this from the practice. So hold on to this until Monday. Now, it's not time to get up and start putting your calculators away because I'm trying to give you guys time to work on this while I can hand you back your notebooks. All right? So, don't forget, I need you guys like, share, and subscribe. Don't forget, hit that notification button. There is a PayPal option here or cryptocurrency. All right.